right now, just continue eating. Well, if you grew up during Star Wars, you're now seeing it. Star Wars is here. Our professor is Mario Savvides. He is the Bossa Nova Robotics Chair of Artificial Intelligence at Carnegie Mellon University. He is also the founder and director of the Biometric Center and holds a tenured position in the Department of Electrical Computing Engineering. What he does at the university is done with his students, and his students have been sent to all major businesses like Meta and so forth. They hold about 100 patents at the university. It's an exciting time to hear him talk. So, please.
Thank you, everyone. Turn on. So it's an honor to be here today. I really thank you for being here. I want to thank Ms. Coderre for the invitation here, and I'm also very grateful to David and Seymour for supporting some of our work that our students have developed here. So we're very grateful. A lot of what we've developed here really goes out to the support they've given us. So I hope to wow you with what basically a small team of students have done that has been outperformed anything out there in industry, academia, and government. So this is our story. This is how we got here. This is what I'm telling today. We're all about how do the students create technology, how do we create patents, but more importantly, for it staying in the lab makes no difference. How do we go from lab to market? How do we make a difference in the world through commercialization? So you will see how what starts in a lab, an academic lab, actually makes make a real big impact in the real world. And that's the theme today, from science fiction to reality. So these are all real cases, real impacts, and historically, the last 2.5 decades, we've been the Biometric Center. That's how I started. I've been working in facial recognition and biometric recognition. And we've now morphed to the Center for Foundational Intelligence, where we're working on developing algorithms that improve reasoning on things that you see every day, now working with ChatGPT, Anthropic. How do we make those algorithms smaller? How do we improve reasoning? And I will talk about all those things and innovations that me and my team of students have developed. Now, I love this because one of the amazing things that we have done, which no one to date has done, is develop one of the longest iris recognition systems in the world. So this is something I've shown at the World Economic Forum, and this is one of the movies, the Mission Impossible movies, where you're seeing, and Minority Report, right? You're seeing Tom Cruise come in and he's being recognized in the gap, and it says, "Welcome to the gap," right? That's about a couple meters. Welcome, Mr. Sakamoto, so-and-so, right? That's science fiction, right? Or is it? So, this system is, and I'm going to show it in a second, we built this system to actually go and do iris recognition. There we go. Sorry, the video. I'm doing live, this is live streaming, so. We built this system in 2009 we started, we finished building it in 2011. You can capture someone's iris about 40 feet away and match them. There was no X marks the spot. Didn't care where they were. This was a huge technological feat. We even showed you could identify someone's iris in a routine traffic stop. One of the largest loss of life of law enforcement is they stop someone for a routine traffic stop and turns out they're a wanted murderer from a different state. There's no coordination among different states on warrants. And that's how you lose our men and women who protect us. So we've showed how this technology can actually be used for good, and not only law enforcement, but also stop human trafficking.
Can we make it louder?
Oh, sure.
I'm having a problem hearing.
How about now, better?
Much better.
Okay, sorry.
I'm sorry to interrupt you.
No, thank you. Please tell me. human trafficking, children being abducted and taken across border. Well, it's one of the most devastating things, and the biggest challenge is children, baby toddlers grow fast. 6 months later, you don't recognize how they look like. Facial recognition doesn't work anymore. And what I've talked about at the World Economic Forum is through iris recognition, you can identify that child, even if they mask them, if they put they try to make them look different through wigs or whatnot. And there's a lot of good that can happen to stop this, and it needs this kind of technology. So my goal here today is to show you and destigmatize you of what Hollywood has done an amazing job to everyone, including myself, in making us scared of AI, making us scared of biometrics, scaring as it is all bad. And I'm here to show you all the good things we have actually proven it does. Not speculative, proven. So this is
Mario Savvides says
and this is our long-range system. It was actually featured on CNN. We were the first to do this system, which, and again, in 2011, we're talking about 14 years ago. We developed something way before its time. Now, what you don't know is that actually a person's iris is unique. The iris is actually the sphincter muscle that controls the dilation of your pupil. As more light, it contracts. When you're in dark, it actually dilates, but that muscle is a unique fingerprint, and it does not change as you age. Okay, that's the key thing. It doesn't change as you age. People can change makeup, can alter their face. You can't change your iris. And if you put one of those Halloween, contacts, you'll say, well, what about contacts? Well, your contacts don't change pupil dilation. Your iris muscle actually contracts. And so you can do liveliness tests to see if someone's actually trying to spoof it. It will not deform. And so we're one of the first universities that actually has done so much work in iris, not only in the recognition aspect, and we were among the top 3 vendors back in NIST when they actually did a competition. As an academic, we actually showed that we developed algorithms that were equally good to the top commercial vendors back in 2007, 2006. So, something to be said about a group of students and the intellectual power they have to go against the world's leading industrial companies out there and government agencies and show we can do better. And that's my driving point. Everything I'm showing you today is done by a team of students and staff at the university. And we're showing how we've taken it and gone from lab to market. This is the same system. And this is my student Dipan. He actually started a startup. He's doing a robotics startup. And that's a great thing. My students go out and do different things. Some of them are in Meta's Superintelligence Lab. Some are in NVIDIA. There's a student everywhere. There's not a company you won't find one of my students out there. And they're doing amazing stuff. And Dipan is doing some work in robotics. Here he's one of my props here. And we're showing that even if you're wearing a mask, we show we can identify someone out through iris, even if they're wearing a mask. Now you'll say, why was this used for? We built this for the government back at the time when the Iraq war was happening. And what happened is soldiers would go out in different villages. There would be a series of IED attacks, improvised explosive device being planted. And so it was very important to be able to identify somebody who's always nearby an event that happened. And how do you do that when everyone is masked? Right? In the regions we're talking about, everyone's wearing a burqa. So iris recognition was the only way to do that. So we built something that they could use as they went to different villages and try to identify. So this was something, everything we do is how do we protect the men and women out there that are protecting our country? At the end of the day, there's someone's daughter, there's someone's son. How do I keep your sons and daughters safe? And we build that technology to keep them safe. We actually worked on the Boston Marathon case. When that happened, the FBI released images that they were not able to match. These were the images that were publicly released on the web on that Thursday, 5 p.m., April 18th. We took those images and started working with them. This was the best image that came out. As you can see, it's extremely a blurry image of Tsarnaev. You can't even think about what he looks like. It's off angle, he's holding a cell phone, he's wearing a cap. Nothing out there worked. Nothing in the government, nothing in industry could do anything with this image. Well, I sat there with two of my PhD students, and we took that image and we applied some super resolution algorithms we did, and we came up with a reconstruction at 2:42 a.m. that April 19th, Friday morning. And I sent it over to CGIS in West Virginia, to the forensic analysts in the FBI in Quantico, and also to a local field agent, FBI in Pittsburgh. And my email to them was, we have no idea what we have reconstructed, if this is right or wrong. That's the image there. Take this with a huge grain of salt. Well, at 9:30 a.m., the brother went and shot the MIT officer. At that point, the image of Officer Knife came out. And you can see the reconstruction we did is actually an amazing resemblance of Tsarnaev. Okay, my brain cannot, at this point, reconstruct what this looks like. But AI back then, in 2013, did. And when I say AI, I say pre-neural net AI, pre-gen AI, right? This was all signal processing, mathematical equations that we applied to do this. And I keep saying that because right now we're entering an era where we're just training neural networks, we're training black boxes, and we don't understand. They work, and we're happy when they work. And when they don't work, we don't know why they don't work, because we're building black boxes. And my foundation is teaching students is we need to understand why. We need to use explainable AI so that there's a workforce that we can go back and figure out when something fails, how do we actually fix it, and not just throw data and hope it works, right? We're entering an era where AI is a black box, and it's a tool that we don't understand how it works. So we have to be very, very careful how we design these tools. And that's what we do different here at Carnegie Mellon. We showed after the fact, we said, okay, well, we reconstructed Tsarnaev's image. What if we had that image and we had a database? How could the algorithm that we developed back in 2007, which was number one in the Facial Recognition Grand Challenge at NIST, how well could we have matched it? Well, it turns out it ranked number 20 out of a million actual mugshots. And I want to step back a bit. When we say facial recognition, people think, oh, I'm identifying, that's the person. That's not how law enforcement works. When you have a crime and you have a suspect, facial recognition, and I've worked with the NYPD real-time crime center, where they have one of the first agencies, law enforcement agencies, that has a facial recognition unit to actually handle crimes and identify people based on their faces. And they have forensic analysts. They don't trust the AI. All the AI does is, I have a needle in the haystack. I've got someone who committed a crime. I have a blurry CCTV image of the person. I have no idea who this person is. They don't look to AI to tell them who it is. They look to AI to say, well, here is 50 people that resemble that person. You, the person, the analyst, the forensic analyst will actually go through and say, yeah, this kind of looks like that person. Let me actually find evidence. Was that person in the area? Was that person in the country? Was that person near the crime scene? So facial recognition in law enforcement is used in an evidence-based way. It is purely a way to find someone that actually you can build a case that, yes, they were there, there's evidence that actually links them to the crime, but at least you know what direction you're looking at. It isn't because, oh, the AI system, it was him. And that's a very common misconception about how AI is being used, particularly facial recognition in law enforcement. And in New York, NYPD has an amazing system. I used to work very closely with one of the former chiefs there, Ken McKeel. He just retired. But I really give him a big applaud for building that first facial recognition unit. The next one I worked with actually was in Tampa, in Pinellas County Sheriff's Office. They have another very good facial recognition system there. And I'm sure now that has propagated. That was back almost 10 years ago that I used to work with them. I'm going to talk about, and our work was, we were featured on, and I'll talk about this. We were featured in CBS 60 Minutes. I'll show a video with Leslie Stahl interview. We were in 68 Minutes. We were in, Novich did a 1-hour documentary, The Boston Manhunt. We were featured there for what we did. And again, we're just a team of students at Carnegie Mellon University developing something that no one else did. And I keep hammering that because we think of university as just a lab where people write papers and publish papers, right? That's the negative stigma we have as a university. We're very different. Even within CMU, my lab is very different. We're very applied. We'll develop theory to solve a real-world problem that it can make a difference. And that's the common theme I hope you see today in my talk. Another thing we did is work on facial detection. So when we worked for an agency called JIDO, the Joint IED Defeat Organization, they were mandated to go and fight ISIS, is they needed to be able to find people that had masks. They couldn't even search them in YouTube videos. So when we tried to do facial recognition in COVID, because everyone was masked and all the commercial systems failed, we already had solved that problem because we built the world's best detection algorithms, not by actually going and training on masked faces, because we will never have enough data that the big industrial giants have. We will never have enough compute that the big government agencies and industrial giants have either. But what we do have is brains. And we're good at developing algorithms that will generalize data better. And that's the key thing, right? Right now, all the big companies are about, well, more data. Just throw more data, throw more compute, we'll make it better. And yes, that happens, but that's an engineering advance. That's not an algorithmic advance. We're all about generating new algorithms and patenting those ideas. And so we've created a huge IP portfolio, and we were actually ranked #1 in detecting faces, hard faces, because if I can't detect a face, I've already figured out a way to bypass your security system. If I can't detect a face, I will never match you. So people will do weird things to just wear masks or camouflage themselves, and they will be avoided by, right? So small things, again, we did. And there's a talk I gave at the World Economic Forum on this topic. We also generated 3D faces from 2D images back then. So we could just do synthetic generation. Again, way before what you're seeing in ChatGPT, we were able to do those kind of things from a single image. We had a wonderful interview with Leslie Stahl on our technology. It was wonderful to meet her and her to interview my students. I think that was their highlight. One of the great things with my students is they will tell you there is no single project they work on. They work on a variety of projects, and every one of them, when they graduate, like, wow, thank you, because I've learned to apply my knowledge to so many problems and get exposure to working with agencies, to working with law enforcement, to meeting great people like Leslie Stahl and Miles O'Brien and many other actors, and be part of CNN interviews. And that's what drives their thirst, is to make it feel that they've done something different, to make an impact, right? Not just publish a thesis. And for that technology that we've built, we've actually gotten very large awards. We've gotten the Outstanding Contributor of AI Award from the Secretary of the Army, Honorable Mr. Ryan McCarthy, because of facial recognition and detection technology outperformed $100 million IARPA programs, even though we only got funded for a fraction of that amount. It outperformed commercial vendors out there competing and working. And again, I'll keep saying this, we're just a small lab in Pittsburgh of about 10 to 15 people with several master students. And yet we can really make a difference. This is a commendation letter we got from the Undersecretary, Mr. Jay McPherson, and it's a great letter where he actually spells out and seeing the technology and getting us the impact. So again, my students seeing a letter from the Pentagon that praises their work, and these are students that could be your grandchildren or grand-grandchildren there. These are someone's grandchildren, daughters working in my lab. They're just students that want to make a difference, and they work with each other. So I run my lab as a one for all and all for one. We all work to work on a problem. We may have sleepless nights, but everyone there helps each other. No one knows everything, but together everyone can help solve a problem. And so I really, really try to instill the whole team environment. Everyone has to help each other. It's almost like the NASA, missions where you get everyone together. How do we help and save the astronaut, the Martian? How do we get that? How do we help them build something there? Get all the scientists together. That's how my students are. Everyone has a skill that the one doesn't, and together we help kind of figure out a solution. We don't have all the answers. All we know is if we put our minds to it and work hard, we'll find a solution. That's the only thing I know. So any problem you ask me, I will say the same thing. I don't know how to solve it, but give me some time, and I guarantee you will find a solution.
Good attitude.
It's how we work. The theme of what we're doing compared to the big giants in computing is not just build larger models. The Anthropics, the ChatGPTs, the XAIs are buying billion-dollar farms of data centers of GPUs. And there's no way we can compete with them because we don't have that much money. We barely have enough money to just pay for the students. At Carnegie Mellon, at any university, PhDs and master students, they're paid. We have to get funding. The university doesn't pay for them, right? They're all funded by something, a government grant, an industry grant, a corporate grant. And so trying to get several hundreds of million or even $1 million to buy computers is very, very hard. So what we try to work on is how can we make a difference on the next problem. Everyone is building large, several billion parameter problems. That's great for the big giants, but that's a very small space that only very few players can work in. So we try to say, what is the next problem? What is the next frontier? And the next frontier is how do you get those models? And I'll show you how we're able to get everything that we're doing to work on this. This is a small accelerator chip from an Israeli company called Halo. And I can run all of the models I'm going to show you next in retail, where I can identify 250,000 SKUs on this chip that costs $150 MSRP. Not production, when production is probably a tenth of that. And guess how much power this uses? Close. 2 watts. That's nothing. 2 watts. When every time you're doing a ChatGPT call, that probably costs several thousands of watts over a couple of minutes. This is 2 watts. And it's local. You have full control of the data here. It doesn't leave on-prem. So when you have this on a security camera, whether it's a home security camera that's monitoring you or helping you, you control what data you're sending. You don't have to send everything to the cloud. So I'm all about how do we make this thing cheaper to deploy, but at the same time control what you give access to the AI. And I want it local, when it's in your hands, where you see it, and you can cut off the Ethernet and you make sure it doesn't go anywhere. That's the future, and that's what we're working. So I'll show you what we've done in this area. And that's what we've done in Ultra and AI, where we're basically commercializing this lab to market, and we're funding the lab to do that. So that's all the lab is being funded to actually commercialize this technology. And just to give you an idea, these are different other small edge devices. What you're seeing here is a double height of this. This is a Halo 8 two-top version. This is a Raspberry Pi. So you know Raspberry Pi, there's very small devices, literally half the size of your cell phone. If you can do all the AI on something like that, then you have robotics. You have a mobile robot that can run around on a battery and do visual understanding. It can monitor. I want to build cameras that I can use and maybe put in a swimming pool to detect if a child jumps in and suddenly, you know what, maybe they're not responding. Or a pet jumped in the pool and shouldn't be there, right? we live lives, and it's all about that fraction of a second that we look away from something and something bad happens. How can we have AI protect that? So that was something that I did in my first lab to market technology. And it's about coming back to it. And I'm going to show you how we've taken this now and revolutionizing retail. So I'm going to skip this, and I'm going to talk about, as I had a startup which we then worked with a company called Bossa Nova Robotics. Why is this? I apologize. Let me try. Okay, there we go. We're back online. So this was a CMU startup, not by me, but someone else, and the CEO was Bruce McWilliams, the CMU Board of Trustee. Bruce was an amazing guy, and he bought my first startup, who were doing security cameras, and then he said, I'm going to fund the lab because I want you to develop technology for robots. He had a company, a CMU startup, that was building robots, and that's the robot they built, and they were scanning aisles in Walmart, but they couldn't solve it. They were sending the data out to a team in India or somewhere, and they basically were analyzing and finding out what was out, and they couldn't go beyond 15 stores. They brought us, they brought my team at CMU, and in 6 months, we completely rewrote the visual AI stack on the robot. We got rid of human in the loop, and the robot was actually doing all the AI. And that's how I started going into retail. That was a pivot from facial recognition to retail in the wild, wild west. And weird things happen in retail. People kick the robots. People will place products. Anything you can think of happens. So if you can work in an unconstrained environment like that, you can do anything. And that's exactly what happened. So I am so sorry. Okay, there we go. And that's how Ultron was formed. Walmart came back to me and said, hey, we need your technology. We want you to continue developing this at Carnegie Mellon. And we want you to actually solve a problem. So Ultron AI was born. Yes, I am a big fan of Marvel. And even though Vision is the good guy and Ultron is the bad guy, always the bad guys get the most attention, right? So we're the bad Ultron AI, but really doing good. And I'll show you what we have developed. And we're basically solving a $32 trillion retail industry, and $112 billion is lost every year in theft, in shrink. And most of that happens by simply, when people check out, they will check out and they will basically take a box of steaks, and they'll put a Wrigley's chewing gum under the box of steaks, and they will check out. Camera on top is seeing that something was being checked out. The barcode scanner is actually matching the Wrigley's chewing gum and said, yep, I saw you pass an item. I just charged you 99 cents for the chewing gum, and you placed it correctly in the bagging area. Thank you. All good. No, you just walked away with a $150 box of steaks, and no one realized it, including the associate who's right there seeing you, because you did this, and they don't know what the barcode was. Right? So we solved that by adding a camera on top and using this to recognize 250,000 SKUs in fractions of a second. In fact, in milliseconds. We can do this in 45%, and I will show you some videos on that. So, and the first thing we did for Walmart actually was cart verification. They wanted to verify carts in a store. Your receipt is what you're working out with the correct number of items. So here's a demo of our system. So you're going and you're checking out, and this is what Instacart shoppers are doing, and the Gigi shoppers are doing. They're picking out items, they scan them with their cell phones, and they put them in the cart, and then they just walk out. They pay and walk out. What we're showing here is that we're not using barcode, but actually we can do visual ID. So you can just take a picture of the product, and it matches what it is, and that's added to your cart. Why is that good? Because now I can do more than that. You can take a picture of a product without having touching it, and it can give you all the nutritional information. During COVID times, we were scared to touch products, right? And you have to pick something, turn around and look at all the information. Well, now you have that at the tip of your hands. So here you get a barcode. You go over to checkout. I mean, how many of you guys, you go to Costco, right? What happens at the Costco? At the end, they ask you, show me your receipt, right? And they take the receipt, and they look at the receipt, and they look at the cart. Do you really think they know what's on the receipt? No. I mean, I've looked at the receipt. I can't decode what's in there. Neither can they. At best, they're counting the number of objects. That's it. We can tell. Now, we can't tell what's under. If you have a stack of things, we can't tell, but we can tell at least what they're seeing. So at the very least, we can actually do what the human is saying they're doing, which is looking at the product and seeing does it match, does anything look out of place. We can do that, and that's what's going on here. So as Christine here, and she's one of the team members that we got from Walmart to join us, everything that's green is a validated item. Now, it doesn't have to be sparse. Most of the time that they use this, they want 10 items or less, or 5 items or less. You can do this with a full cart. Now, red items are items that are not in the receipt. And anything that's flagged red, hey, wait for an associate, someone will come out and check. So we want to automate. We want to create ways where you can just check out quickly and don't have to look at a person to stop you. So faster way to process through lines. This is our shrink detection at checkout. We are actually detecting what a product is being scanned, not just the barcode. So this is a data logic scanner. This was a normal scan, and basically the camera on top correctly corroborated what the barcode said. Now here, Christine is basically covering the barcode. So what happens sometimes is we don't realize it. Okay, you may be covering the barcode of an item, and you cross it, and then suddenly you have an alert. Please wait for an associate. Well, I didn't do anything wrong. Why is an associate happening? How many of you guys faced that? Raise your hands. Yeah, all the time. I hate going to self-checkout because you're doing nothing wrong, but we're delayed for stupid things. Why? Because checkout right now is behavioral. It's not deterministic. They don't know what the product is. If I can identify the product, then I can say, oh, you know what? Yeah, I know it's whatever rice-a-roni it is, and I'll just charge it, and I won't stop you because you're not doing anything malicious. You weren't trying to steal anything. You were just wiping, and you didn't know that you were covering the barcode. This is the things that AI can actually help make our lives faster because there's less people in checkouts. We have less checkout man-type humans now. And we're forced to go to self-checkout. And it's a terrible experience. I hate it. So we are changing that. We're changing that. We want that experience to be good. And one way is to understand what we're seeing. So with our technology, hold on, sorry, I went back too fast. Sorry. There we go. I'm going to go again. Sorry. These are cool videos. I want to make sure I show them. So we did the barcode skip. So here, Christine is going to, okay, that was the skip. The next thing is she's going to do the whole ticket switching. She's going to place an item. She's going to do the whole, I'm going to try to steal. I'm going to place this cheaper item under. Now, imagine that's a Wrigley string. We don't have a Wrigley string gum. The barcode scanner saw this item at the bottom. Our camera on top saw this and said, hey, I'm seeing something that wasn't scanned here. And so now we are stopping the number one way people steal in the stores. And this is actually why you have all the other behavioral. So we've now taken out probabilistic behavioral matching that has a lot of false positives to a deterministic method. Let's actually know what they're doing, what's going on. This will remove the need of having someone continuously watch over you. How many times are you checking out and somebody just comes over you and saying, what are you doing? I'm not doing anything wrong, I'm just checking out. Why are you looking at me? Right? AI can solve that, make it a better experience and make you feel like you're not being watched. All it's doing is looking at products and doing it fast. So, The next thing we're doing is, okay, you know what? Forget the barcode altogether. I don't want to have to move the product to find where the barcode is and do this. I just want to be able to, if I can see it and I put it there, if I can understand what it is, then so can the system. That's what we want. And that's what we've developed. Okay, I think that was it. Thank you. So, now you can just place the items and you can identify them. This is the future of checkout. Multiple items, if you can see it, so can our system see it. No more barcode scanning, no more figuring out what angle. Oh, I didn't scan it correctly, I didn't do it and you're fidgeting, or the barcode's torn, or the stickers come out or whatnot. So, and again, all that is running on this, on currently deployed kiosks. So this is an ELO kiosk. They're the #1 manufacturer and deployer in all convenience stores, in many restaurants. So for us to insert our algorithm is them adding this in where they have a hard drive. So we're not building your hardware. We're not manufacturing. We don't have manufacturing cost. We're a software upgrade and as easy as a hard drive upgrade. So ELO is our partner. They're deploying our system right now, and we're working with them with some other things I'm going to show you in a bit. We can also take care of conveyor belts. We can reuse conveyor belts and actually do like a scanning station. So as you're placing, you go to a store and there are many people that are just, the conveyor belts are not being used. Those stations are empty. Turn them into a self-checkout, where now you're placing the items, and guess what? When you're placing the items and it's moving, you're creating this natural spacing between items that is actually very easy for the system to understand. And you have now just a bagger that bags your items, and that's it, you're done. So I'm showing you the same engine, the same hardware, having all these different applications that we can solve. This is one where we're doing inventory check. So we can actually scan, have a camera, look at the shelves, and figure out if something's been misplaced. So everything here is white is in the right location, and if you click on an item, it'll give you all the information you need. So it could be your cell phone, where you just want to figure out your nutritional contents, and I want to highlight, show me all the items that are above 20 grams of protein, right? It could do that for you, very easy. Or for an associate, you can find a misplaced item or out of stock. So for example, that type item in blue, that's an out of stock item, that's what should be restocked. So it can help the associate. The #1 thing associates spend time on is actually finding misplaced items. I'm guilty of this. I'll pick up something and then I don't want it, I leave it somewhere else. They're playing Where's Waldo at the store and trying to find this like several items, and it takes them forever, and they hate it. So when we talk about AI and we hate AI replacing jobs, no, AI will replace mundane jobs. It will replace things that we hate to do. And that's a great application of it. Yes, let it do the things that we hate to do. Help us so the associate can spend more time helping customers, helping you find things, giving you a better experience. Not, you can't find anyone because they're running around doing inventory. Here we go. This is the, we're now putting them on augmented reality glasses. So we're getting the same technology, work not only on this, but actually even smaller silicon that's embedded. This is a demo, and we demonstrated this NRF. What you're seeing here is somebody wearing the glasses, and this is what they see. So this is now in customer mode. Imagine the future where everyone has a Meta glass or a Radio glass or Snapchat glass or any of the whatever new glasses, and you're walking through, and you know what, you put in a mode, hey, I want to know what's on sale. You know what? Give me anything that's 30% off on sale. Well, this is what exactly it's doing. It's highlighting anything in purple, that's a sale item. Okay? And how would you know this was on sale? You look at the tags, but this changes all the time, right? So you can, it will revolutionize not only the customer experience, but also advertisement experience. If the system knows I'm looking at this particular item, this goldfish, Well, the competitor can give me a better deal. Say, you know what? I'll give you 10% more if you buy this now and show it to you live. That's a whole new experience of brick and mortar that we're not even thinking about, but we want to get ahead on. And it's all being developed in my lab. Now, let's go to associate mode. Associates are trying to find things that are out of stock. So this item is misplaced. Now, this was a demo that we did in a ref. We rented a suite, and we had folks come in from retail, and we were demonstrating them. The red shows that this item is the wrong place. The dot shows where it's supposed to be. Granted, it's right next to each other, but imagine that it's actually different shelves or shelves away. So now the associate knows what has to be moved, and it knows where it's supposed to go. And the moment he moves it there, it becomes green. It's the right location. Bingo. Yes. That's just one application. Imagine the possibilities of this technology. Endless applications. And then there's more here. We're using augmented reality glasses where you're seeing what the product is. Maybe I want to know anything that's 20 grams of protein and only 5%, 5 grams of carbs, right? It can just highlight those things for you automatically. How many times do you pick out like, well, how many carbs? Oh, this is something new. I don't know what it is. How many carbs? Show me those things so I'm not wasting my time, right? Time is money. Let's get to the things that we care about. Let AI help us. That's the power of AI. Let's use it to save our time so we can spend it with our loved ones or doing things we want to do, not end up searching things. That's what stores want us. It's like casinos. They want you to be lost in this slot machines. No, go and find what you need, help you. Let AI help you do that. So I have a ton of more of those. I'm going to quickly go through them. We are right now commercializing the technology with ELO, Data Logic. We have Zebra, MishiPay, Retail, Walmart evaluating this, and in the pipeline we have CVS, NVIDIA, Intel. Again, we're a lab of students and staff developing something that the big giants like NVIDIA, Qualcomm, Intel are interested in and make a difference. Something that you will see in your store. Coming to you in a public store in your neighborhood will be our technology, hopefully soon. Right?
He doesn't want to talk about, but tell him about one of your students doing this with the trading of stocks.
Where,
Don't do it.
okay, so I haven't finished, but my students are always looking at new things. There's algorithms that some of them are looking at to look at better stock prediction. Now, you can't handle a lot of money under that, but if you put some money in there, it will give you very, very strong returns, and that's something we're looking at. So,
Yeah, tell them how much money they make.
we can talk afterwards. This is not yet productized or any.
I have a question.
Yeah.
You have a new business. That's what.
We can't hear it louder. We have a microphone. Wait for the microphone.
You have a new business.
I can't.
Where does that money go? Does it go into the institution?
Yes. So all Ultron is 90% of it is going back to the lab. We have some engineers there, but all of it is going back to the lab to fund all the innovation, all the development are by the students. That's what we're trying to do. We want to get away from just government contracts or this and that. So we're funding all the students to develop. That is every new commercialization, lab to market. The goal is to get money back to keep funding the students to continue innovation.
And I have a question. People who have invested, do they have people who have invested in your production?
Yes.
Do they get a return?
Of course, when the technology is sold. So you, Wilma, you just took the next. The great thing is we developed. Thankful to the government, we developed over 100 patents. We've commercialized that, and we've commercialized that, and we have investors. And David and Seymour are one of my biggest. They are my investors actually in Ultron. We're funding the lab, but at the end of the day, when this company is sold, the IP, they're going to get a huge return. Hopefully 2x and beyond in a very short amount of time. So if we can 2x money in a year or so, or more. And not only that, but students get back too. Students are not part of the company, they're part of the patents. CMU is an investor, meaning there's equity, they get distributions as well. So they all make money when this is successful.
I have a few questions. Is the technology cost prohibitive for businesses to purchase it, to install? I mean, they're great ideas, but it does cost something for a company to adapt it to their program. Is that correct?
The cost is actually the opposite. The cost is, do I build or do I buy, right? That's the question they have to ask. And there's two answers to that. A, we have the solution. So it's going to cost them time and money to build it, where we already have a solution. Second is we have patents. So one of the things I'm going to show about here is, and I quickly, we have, what I specialize in is actually patenting not only offensively, but defensively. So if somebody right now is building a neural network where they're using synthetic data that was generating from a single image. So if somebody took an image of this Fiji water, okay, and generated a 3D model, very much like what we're showing in one of our product lines that we developed at the lab, and using that to train the model, which is what everyone is doing, we have a patent on that. So that stops them from being able to commercialize or use it. They have to use us.
Right, but it costs, but that's what I'm saying, it costs the company something to be able to use that model. Isn't that correct?
Well, yeah, they have to buy it from
So I
somebody.
understand what I'm asking. I'm asking, is this cost prohibitive for companies to be able to buy this and use it? That's what I'm asking.
Not when the fraud is.
Yeah, well, yeah. When you look at the the $112 billion loss in retail, when it costs them 1,000th of that or less, yeah. No, when we're deploying this, we're literally deploying it. We're talking about $100 a month for a point of capture. No. And that's on the high end.
That was my question.
Oh, I'm sorry. Yeah. So yeah, we're not. This is and so on your next question on the cost prohibitive, it's not the AI that's cost prohibitive. The biggest cost prohibitive of every other solution that's trying to build it is they're using hardware on the cloud, and it costs a lot more, or they buy on-prem solutions. If you remember Amazon Go, the Amazon Go, it literally cost a couple of $1 million to install the camera infrastructure to do that. And it still didn't work because they had a whole team somewhere actually looking at the results. It wasn't 100% AI driven. This is now, we're talking about $50 hardware deployment. That's cheap. So cost prohibitive is not only the AI, it's actually, typically the solution has been too cost prohibitive from the hardware perspective. That's why we're developing Green Eye AI. We can make it work on the lowest possible hardware platform so it's not cost prohibitive. So I apologize. The last couple of days I've been working late night shifts, so I need a...
Yeah, I have a question.
Yes.
I have a question. My great-grandfather had a grocery store and a meat market back in late 1800s. People would contact, they would take a horse in the delivery, deliver it, and then it evolved to just calling, and they'd write it on the bag, take it, and they'd market it. But the other side of that is a robot could have replaced you to make this presentation.
Oh, absolutely. I not a robot, a virtual AI.
I'm not saying you weren't good.
I am saying my digital twin would have done a better job, but the only problem is if it was cloud driven, it would have frozen mid-time like me.
Yeah.
Right? So that is the problem. If we depend too much on AI and on the cloud, that wouldn't have worked. And most robots, by the way, that's one of the, we're developing this for retail, but at the end of the day, this is going to go into robotics. And this is what's going to make robots work when they're less dependent on making API calls to the cloud. Because a robot doing a task and then suddenly freezing because it doesn't have lost internet connection, is not a great experience.
I'd like to ask you about the process a university goes through in order to get a patent approved. It's very interesting that you have been able to accomplish at your university some kind of companionship or a sophisticated system where they will let you be have a commercial result at the end of the process. And I'm just wondering whether other universities in America are able to take advantage of what's going on in labs, and what some of the recommendations you would make, because you obviously have been successful.
You know what? That is an amazing question. And yes, it does vary from university to university. We're very fortunate. Carnegie Mellon is very pro lab to market because they want to make an impact inside. That's why we're number one in AI, because it's not about just developing theory, it's about actually deploying it. Some universities have a very, very slow tech transfer office that they want to do that, but the whole process is so much red tape that faculty just will give up. And I'm hoping.
And what about the cutbacks in government funding affecting all of this?
Absolutely. That's one of the reasons also that we're going, our lab to market is we want the new commercialization efforts to actually fund the lab back so that we're not dependent on funding being cut, because everything now is more driven to more industry. So how do we as academia keep up to that? We have to be an industrial arm helping, otherwise we won't innovate anymore. So we're adapting to those. Fortunately, we've seen the writing on the wall for some time, so we've adapted to that before what happened in the last 2 years, right? But it is a huge issue, and that's why a lot of labs are hurting, because they've had the grants cut when they were doing basic research. And so you need to do something that's very applied so that you continue to get commercial funding.
Yes, I have a practical question. You mentioned it's kind of twofold. One is sort of technical and one is more practical. The technical one is surely there has to be a process for inputting the prices so that the thing can read it, okay, and visualize it, and perhaps that comes from the barcode, because I just was curious. You don't have to give me the detailed explanation, is that just a simple thumb drive, for lack of a better word, is it? Because that takes time. And the second thing, more important question, more practical. You mentioned, if this is successful, So are the results in from, say, a Walmart that's been published or shared in industry data successful, meaning shrink loss goes down, profitability goes up? Is that in yet?
Do we have end results? Unfortunately, due to NDAs, I cannot talk about the results. Shrink is a proven problem. We have seen it. Yes, and I'm sharing here a video of just in January. This is ELO, the CEO of ELO. So ELO is our commercial go-to-market partner. They are right now deploying this. Our technology is so good that it actually outperforms the speed of a barcode. The CEO has said, can I just throw this across? And again, everything is running on this chip, on the old POS. Okay, just as a note, we're not using some high-end GPU that costs thousands of dollars. It's using this micro thing onto the PCIM2 of the POS. So Craig is literally throw that over, and it actually matched. It's a bit low resolution. It matched. The barcode reader didn't even see it. The camera on top matched it. So, and I can tell you, we've had multiple CEOs come in and basically take and start selling, and actually David was there, and David and Andrea were there, seeing this, where Craig came and pushed me out and said, Marius, I want to show this. And he showed this to Target and some others, like, look at this, how fast this works. So, going back to your cost prohibitive, it has not only been cost prohibitive, AI has been compute prohibitive and speed prohibitive. AI was not fast enough to be able to do this. It took seconds. Not good enough for retail environment. We are impatient in retail. We are impatient people in general. We want things fast, and they have to work fast, otherwise we don't use them. That's why we have to develop algorithms to make sure they run fast and they run cheap.
What companies are you currently in negotiations with to purchase you?
I am not at liberty to disclose that, but I can tell you we're talking to many.
Yes.
I am not, but we are. Actually, I can't say anything. We are in the mode that we have actually been in stealth mode. We have come out of stealth this January with this video in NRF. In NRF was our big debut to the world. And since then, we have a big pipeline of people looking at us, evaluating and talking to us.
I have a question.
Yes.
This technology is very good at identifying people. It could be used negatively by, let's say, a government to identify people, and let's say working in China, giving you a social policy that you cannot go certain places or do certain things. What guardrails or technology would you recommend to stop that? Because it's inevitable something like that would be applied.
Well, my technology is not running in China, I can tell you that. My technology is not running in China, I can tell you that. My technology is not running in China, I can tell you that.
Somebody else's.
But somebody else's, yes. So to your point, that is a problem. I mean, China is developing their own technology. There are facial recognition companies, and they are absolutely using this. It is a very big problem. I, as an inventor, can control who I give it to and who I sell this to. But I can only stop other people from inventing similar, less superior technologies to do this. And this is why we have to be, as AI engineers, ethical on what we do and who we sell it to, right? We cannot stop the technology from being built, but we can make sure that this ends up in the hands of something that's being used for good. But what you mentioned is a problem that is not just your concern, it's a concern to us, it's a concern to our whole government.
I have a
Wilma.
question again.
Yes.
About,
Oh, sorry.
Well, I just wanted to repeat the question regarding Nancy Guthrie. Has anyone approached you for that? And I'm wondering if they had worn sunglasses, would that prohibit you from seeing irises in the people?
Okay, so that's a great question. Great question. Sunglasses are not prohibited from doing iris recognition. The problem is when you're using CCTV footage, you're not doing iris, you're doing periocular, visual. So yes, sunglasses would block any features we have to use, right? Because I'm using information that you and I seeing. In iris recognition, we're not. We're using different wavelengths. We're using things, a different sensor. We don't have that in CCTV footage, right? We don't have those iris sensors deployed there. As John Dogman would say, can I do iris recognition if I put a brown paper bag over my head? Yeah, I can't tell you who you are.
Guthrie.
the question.
I have to look at the case. I have not had to look at the case. I have not looked at the case. It has been a while since we've been in facial recognition. We have moved in retail. We've stepped out, and that's why we're trying to now actually get better about deploying technology and getting these tools out to people that are using it. We've never productized our periocular recognition algorithms, which is something I want to be done because then they can be used. Yes.
My question still is, I understand the output and how wonderful this is. Why is it using less energy?
It's not going to CPU.
Why?
Well,
Why is that little object using so little? That I don't understand.
Well, okay. So it's not, the answer is not that this can do the equivalent of 1,000 watt. This is a limited compute chip. The reason we're ahead is that we can miniaturize the AI so it only needs the miniature amount of compute that lies here. That is the answer. It is not that this thing can miraculously shrink what 5,000 watt GPU can do. It cannot, right? Obviously. Yeah, we are developing the neural net models that are small enough to actually work on this.
That's the final thing that's important.
And that's why that's something us as a lab can do. We can come up with the algorithms. That's not something you can go punch in Claude and ChatGPT, hey, come up with a model that will do that, right? No, we have to actually develop new algorithms to do that.
Am I going to talk?
That's a great question, and I get that all the time, and it's something that people oversee. That's a great question, Wilma. Thank you.
How much time's left?
So are you not going to speak about the
One
stock
last,
market?
Marius, one more question. He
Yes.
said.
a comment. Using your eye technology, working with the police in Texas, you can help find the kidnapper for Nancy Guthrie. I will donate $50,000 to your college. My name is Fred Wright.
I will start my team looking at it.
Okay.
Thank you.
Yeah.
Yes, you can talk. Let me finish. Let me get through. Yes.
We're running
I'm gonna
out.
wrap up.
We're running out.
Okay. Very grateful to our government sponsor, General James Richardson and Laura Richardson. I think you guys have met James Richardson. He's been he formed the Army AI Task Force at
No, I'm gonna
Carnegie
give a
Mellon,
quick
and
talk.
he's
Come
funded a
on.
lot of my
Oh,
work.
we're
He is a wonderful man, and we're very grateful to his support.
We're going to talk about AI in the labor market.
So I will end with a couple of things. We've gotten Inventor of the Year awards, and we also just elected into the National Academy of Inventors as a fellow. More importantly, I'm very proud of Carnegie Mellon, as you can maybe have realized, I don't know. We are honored, and that we are actually giving an honorary doctorate to Jensen this May. He's giving the inaugural speech at the graduation ceremony at Carnegie Mellon, and he's getting an honorary doctorate. So we're very proud of the AI that we're doing, and we're very proud of forging strong relationships with the giants out there that collectively together we can make a difference. And towards that, I want to really thank again my current sponsors, David and Seymour, they're the reasons we have developed everything you've seen in this slide in the retail world. And I will end with one last video, if it works. Oh. You know, just Murphy is... Okay, I'll just talk about it. One of our commercial customers of another deployed solution, you asked about what our deployment solutions are. We're doing returns. We're actually analyzing X-ray images of returned products to verify that what people have returned is the right product and not replace it with a fake product or something missing. So no, people don't have to open up the box. We're looking at X-ray image to do that, and this company is paying us $50,000 a month to develop that for them. So that's another one of our deployed solutions, which is a bit of a different vertical, but we're very good at analyzing images. That's what we do. So thank you so much. I appreciate. Sorry for so many slides, but I'm here for any offline questions. Come up, see me. I have a card, and I love to talk to you. Thank you again, Dale, for inviting me. Thank you for being here.